The broadcast is now starting. All attendees are in listen-only mode.
Hi, my name is Jeff Demore. I'm with Converter Accessory Corporation, and thank you for attending CAC's webinar on role handling. Just a quick note about questions. I will be answering questions at the end of this webinar, and you can type questions into there's a chat box that should have started up when you started the webinar. And you can ask questions at any time. However, I won't be answering those questions until at the end of the webinar. I'll just answer all questions. So enter them at any time, but again, I'll be answering those at the end. And I do apologize ahead of time if I don't get to your particular question, but I'll also be giving out my email address, and you can always email me questions as well. So let's get started. Today we'll be speaking about role handling equipment, and we're going to talk about what is role handling. When we talk about role handling, what exactly do we mean by that? We're going to talk about why role handling is important to your operation. We're going to talk about different types of role handling equipment and how they work, and we're going to talk about the advantages and disadvantages of each type. And finally, what you should really consider when you're looking for role handling equipment, the kinds of things you should think about or consider in your facility when you're looking for role handling equipment. So first of all, what is role handling? When we talk about role handling, we talk about moving roles around your facility. Basically, you have to get raw materials or stored materials in your facility to your converting department or your processing department, and then you have to move them from your processing department to your shipping department to ship out to your customers. So the question is, how exactly do you move rolls around your plant now, and what kinds of problems your current system may be causing you? Another aspect of role handling is many times turning rolls of material. Most of the time, rolls are stored and shipped perpendicular to the floor, or some people say eye to the sky, where the core is facing straight up and down relative to the floor. And as we all know, most converting machines or processes process material parallel to the floor. The reason rolls are stored perpendicular to the floor is so that you don't get most of the time is so that you don't damage the roll or cause a flat spot across the roll. And then again, rolls being processed are processed parallel to the floor. So the question is, how do you turn rolls 90 degrees in your facility now? How do you get them from perpendicular to parallel? And the question, it's important to ask yourself how you're doing that now, and take a look at different types of role handling equipment that can help you to do that safely and efficiently. OSHA says that back injuries are really the nation's #1 work safety problem, and on top of the pain and suffering borne by employees, back injuries alone literally cost industry billions of dollars per year in the United States alone. And also, if you improperly handle rolls, you can damage rolls, and when you damage rolls, that's profits right off your bottom line. There's an OSHA fact sheet that refers to gives you some numbers as far as what back injuries. The statistics on back injuries is what I mean to say, and the website is listed here. And really, one of the things that I found while doing the research for this paper is that, for this presentation, is that there really is no one specific weight limit for a given industry or process, but there is guidelines on how to there is ways to calculate how much weight limit a person can specifically manhandle or pick up or move around. And I apologize for the small print, but if you go to this website, it's a long one, but if you go to this website here, there's a worksheet that you can print out and fill in some numbers, and it gives you a good idea of how much weight limit a specific person can handle in a specific application without mechanical assistance. So one of the things that's important to do is really to ask yourself, how do you currently handle rolls? How do you currently turn rolls of material in your facility? I've seen this done a lot of times where you have a heavy roll of material. Believe it or not, the roll in this photograph weighs about 800 pounds. It doesn't look like it's that heavy, but it is. And the question is, how do your operators currently turn rolls of material to get them from perpendicular to a perpendicular to a horizontal position? And a lot of times the guys will just take a pipe and stick it in the core. You create a lever arm here, and they pull down on the pipe, and that allows this roll to basically fall over, and that's your turning process. And obviously you should never do that. Number one, employee safety is a concern. This is really a back injury waiting to happen. Plus, the question is, again, this is a very heavy roll. You got feet in the way. You could, if it falls on somebody, you could cause some damage there. And also roll damage. When this roll comes down, what are you going to do to your roll of material itself? Are you going to cause any of the outside layers to get damaged? And are you going to wind up throwing away material due to the fact that the roll was improperly turned? Another question is, how do you currently move rolls around your facility? Again, this roll is a very heavy roll of material, and even with two guys handling it, this is a big no-no. You have definitely a back injury that's going to happen here, and also, again, employee safety is number one, but again, you can get roll damage when you try to move this roll around. Are you going to run into walls or run into some other machine in your plant? Are you going to cause your material to get damaged? So we're going to talk about equipment that mounts on fork trucks. We're going to talk about overhead devices, walk-behind units, units called tilt tables for turning very heavy rolls, very heavy loads. We're going to talk about robotic systems, and really a picture is worth 1,000 words. So when I did put this presentation together, I made it mostly up of a bunch of photographs to give you an idea of different types of web handling equipment that's out there, that's available to you. So instead of really getting into the nitty-gritty about how all this equipment works mechanically, I thought it best to give you options or ideas on the types of equipment that is out there, so you can get if you're looking for roll handling equipment, you get a good feel for what's available to you to make your operation the most efficient. So first we're going to talk about fork truck, clamp truck devices, and these are very common in very heavy applications. They can handle rolls up to about 10,000 pounds. Basically, they grab a roll from the outside. They're very rugged for very demanding applications. You'll see them used a lot in paper and paperboard applications, and they're designed to mount to the mast of a fork truck. So you're taking your fork truck and you're making it into a clamp truck device, and they do swivel to give you the perpendicular to horizontal or perpendicular parallel positioning of your rolls. This is a good example of a clamp truck device. So you can see it just uses a standard fork truck, and then up in front, instead of having forks, you have this clamping device they're hydraulically operated, and you grab your roll from the outside, and you can see the very large rolls of material that this device is used for. These are very large rolls of paper, and you can see how the orientation of this clamp can go from parallel to perpendicular. You can see how it swivels 90 degrees to give you the roll turning. Some advantages: they can handle very large rolls. You can move, turn, and load and unload your machines with this piece of equipment. They're very rugged for very demanding applications. Again, used a lot in paperboard applications. Pretty easy to use. You can handle multiple rolls, so if you want to grab a stack of rolls, you can do that, especially on a slitter or a slitting application. But the rolls would all have to be the same OD because you're grabbing the roll from the outside. They're used a lot in the paper and paperboard applications. Um, the connection of the roll to the fork truck itself is a rigid connection, so there's what's called there's no roll sway. I'm going to show you some other fork truck mounted devices that have a flexible mount that you may get some roll sway, so I'll define what that is later on. Some disadvantages, you're grabbing the roll from the outside, so you could damage the outside layers of some materials, so for that reason they're really not well suited for foils and films. They won't work for small rolls, generally used for big rolls, big heavy rolls, applications like that. They do have hydraulics which require maintenance from time to time. They're relatively expensive, and what makes this even worse is that you're really limiting the use of a fork truck. It's not, when you use a clamp truck device, you're basically dedicating a whole fork truck to being a clamp truck. It's not real easy to swap out the forks for the clamps. You can't make that change, so you're really adding to the expense. You have to dedicate a fork truck to this item. And again, if you're handling multiple rolls, they all have to be the same diameter on the outside. Now there is a fork truck, there's some fork truck mounted devices that use a probe, and there's two types. There's a rigid probe where the probe is rigidly connected to the fork truck. There's also a fork truck device that has a flexibly mounted probe, which we're going to talk about that too. Mainly used for smaller rolls up to 2,000 pounds, and we're grabbing the roll from the core, not from the outside. And these units are designed to mount to the mast or the forks of a fork truck. There's a couple of different designs. I'm going to show you both. And the probe pivots 90 degrees to give you the horizontal to perpendicular positioning, and vice versa if you're going from perpendicular to horizontal. Now when I talk about probes, we're going to talk about core probes quite a bit during this webinar. This is an example of one core probe. Basically, the way this unit works is you have teeth, mechanical teeth that are actuated by this shaft inside this probe, and these teeth travel outwardly from the center out, and they will penetrate your core. So your core would be sitting on top of this. This would be inside your core, and these teeth come out and they grab your core. When you, with this particular probe, when you hook through this eyelet and you lift up, what you're doing is you're literally lifting up on this shaft, the center shaft that's shown in purple, and it's causing these linkages to push the teeth out into the core. And then to release this particular probe, when you grab the handle and you squeeze this handle up, you're pushing the shaft down, because here's your pivot point. And when you push the shaft downward, the linkages cause the teeth to retract into the probe to release it from the core. Now the interesting thing about this core probe is that if you look at the design, is that the heavy roll weight, or the weight that's on the eyelet at this point, this weight here, will never allow you to squeeze this handle while there's weight, while it's holding a roll of material. So you have a heavy roll of material up in the air, and if you try to squeeze this handle, because the weight is on this eyelet, it's not going to allow you to squeeze the handle. So in order to squeeze the handle to release the teeth, you have to completely release the weight so that you can squeeze the handle and allows that shaft to actuate downward, and then pull the teeth inward. So this unit is actually very safe, because as long as there's roll weight on this probe, the probe cannot be removed from the core. So it's a very safe unit to operate. But that's a good example of, when I talk about core probes, that's an example of what I'm talking about there. Now this is a fork truck mounted devices that uses a core probe. Here's your teeth out towards the end, and these units are designed to mount to the mast of a fork truck. You can see could be a fork truck or a walk behind. This is a walk behind unit. This is a small fork truck walk behind unit, and again mounted to the mast of that. And then this probe pivots 90 degrees to give you perpendicular to horizontal position. Again, that's giving you that pivots on this pivot point right here. So when you actuate this actuator, this probe pivots 90 degrees. And that gives you the roll turning. Some advantages, relatively simply designed. They're easy to use. You can handle multiple rolls with one probe. So if you're dealing with a stack of rolls, you can handle that. You can have remote mounted controls for the probe device, or you can have controls mounted right on the fork truck unit itself. The probe can be powered with electric, pneumatic, or hydraulic actuators depending on what you have available there, where the probe is located. There is no damage to the outside of the roll because you're grabbing the roll by the core, and you can move, turn, load, and unload all with one piece of equipment. And again, the rolls, like the clamp truck device, the rolls are held rigidly to the fork truck. There's no roll sway. Some disadvantages, really, these are designed to handle rolls up to about 2,000 pounds maximum, and the probe to core alignment is relatively critical with this unit. If you take a look at the picture, you can see where since this probe is rigidly connected to the fork truck, it's important to have the probe directly in line with the center line of your roll of material. So if your roll of material is out here, and let's say your core is in this location relative to this probe would actually have to come down to line up with the center of the core, and that can be difficult to do. So that can slow you down a bit, or slow your operators down from grabbing rolls with this piece of equipment. So it could be a difficult process. They can have trouble with plastic or metal cores. Any unit that has a probe device can have that trouble, and the teeth in the probe can damage cores over time. So if you do reuse your cores a lot, that's maybe a consideration for you. You always have to have that as consideration anytime you're using any device that has a probe. Roll telescoping is always a concern because you're grabbing the roll by the center. So if the roll is in a perpendicular position, you lift it up. The question is your roll going to telescope off the core? And but there are vacuum plates that are available to help you if you have telescoping as an issue. The roll weight is completely cantilevered away from the fork truck, so if you have a heavier roll weight, depending on the design of the fork truck, it could cause the fork truck to be unstable. Now this is a fork truck mounted device that has a flexible, what I call a flexible mounted probe. Now here's your probe device, and you can see it's mounted inside the roll, but instead of being rigidly connected, here's your fork truck back here in this photo, instead of being rigidly connected to the fork truck, this unit actually mounts right onto the forks of a fork truck. So it's very easy to make this type of system from a fork truck to a roll handling device and back again. But as you can see, the probe device is not rigidly connected to the fork truck itself. So you can get, with this type of device, you can get some roll sway. This is where the roll can kind of freely move underneath the forks, and that may or may not cause you problems depending on your application. And basically the way this unit works is you have a rigid, or you have a fixed point of suspension, and then you have we use a marine battery with a electric hoist, and that by activating the hoist you can get that 90 degrees of rotation. So this is halfway, this picture is halfway through its rotation, and then this is perpendicular to the floor. Some advantages: it's easy to change from a fork truck to a roll handling device and back again. The roll weight is now centered underneath the fork, so the stability of the fork truck, you can see your roll weight is where the weight is supposed to be on a fork truck. So instead of being cantilevered away from the forks, it's right where it's supposed to be. So it can be more stable than a rigidly mounted probe type. They can handle multiple rolls with one probe. So if you have a stack of rolls to handle, it can handle that. There's no outside roll diameter damage because you're grabbing the roll by the core. You can move, turn, load, and unload all with one piece of equipment, and they are pretty well suited for smaller rolls. They have a flexible point suspension, so it makes it a lot easier to load the probe into the core sometimes, because it's easy to just pick up that probe and move it where you want it to be to get it inside the core of the roll. Some disadvantages: really, these units are only designed to handle rolls up to about 1,000 pounds. The flexible point suspension, again, does have more roll sway, so as you're moving rolls around with this type of equipment, the roll can move around underneath the forks. And as with any probe device, you could have trouble grabbing plastic or metal cores. And probe damage to cores is always a concern if you recycle your cores. Roll telescoping, any probe device roll telescoping is always a concern. So when you get that roll up in the air and you turn it 90 degrees to be perpendicular, or if you're starting in the perpendicular plane and you go to lift the roll, again, is the core going to get pulled out of the roll? That's always a concern. There are overhead devices. There's two types. They use a single overhead hoist and a dual overhead hoist. We're going to talk about both. Most of these units are designed to handle rolls up to about 2,000 pounds, and they all use probes to grab the roll, and they swivel to give you north to south rotation. Core probes pivot 90 degrees to give you the horizontal to perpendicular positioning, and vice versa. This is an overhead device that uses a dual hoist. You can see underneath the I-beam there's a tandem hoist assembly that allows these two hoists to pivot. So these can swing 90 degree or 360 degrees to give you the north to south rotation. And when you activate one hoist, you can see, or when you activate both hoists, that gets the roll up in the air. And then when you activate one hoist, you can see how you get your 90 degrees of rotation. So you're going from this photo shows perpendicular, this is horizontal. So you're going from perpendicular to horizontal positioning. And that's just a close-up of the probe. But basically, one of the things you want to keep in mind about this assembly, this type of assembly, is whenever these are designed, this pivot point right here is always at least half the width of the roll and maybe even a little bit longer. And what that allows you to do, the center of gravity, by getting this pivot point out here, you're getting the center of gravity to the center of the roll, and that allows you to have the roll at a truly, you are allowed to position the roll at a truly parallel position to the floor or to a cart that you're going to lay it on, or even onto a cantilever shaft. You can get that true parallel to the floor positioning. And with the single overhead devices, which we're going to talk about, that's really impossible. You can't get to that position. They're relatively simple, pretty easy to use. The best thing about them is that they do orient rolls truly horizontal or perpendicular. So you won't damage your rolls when you're lowering them onto a table or onto the floor, and it makes it very easy to position the rolls relative to a cantilevered shaft. They're not quite as stable as single overhead hoist systems, which we're going to talk about. You do get more roll sway with these systems, and they do require two hoists to operate, so there is more cost and more complexity involved there. And if you want to get that north to south rotation, not everybody needs that, but if you want to be able to rotate the roll north to south underneath the hoists, you do need that tandem swiveling hoist assembly that I showed in the photos. It's a good example of a single overhead hoist system. This system literally only hooks on, you just have one hook that comes down, goes through that eyelet right there, and this probe pivots. There's an actuator, and here's your pivot point. So here's your probe teeth, and you would load this system into the core, and the teeth would come out, grab the core, allow you to get the roll up in the air, and then this actuator, I think this one is electric. This electric actuator allows you to pivot the roll 90 degrees. So this gives you the swiveling at this pivot point of 90 degrees. Here's another system similar. You can see you got two electric actuators on this system. This has very nicely mounted controls right on the system. Makes it real easy for the operator to use. Here's your teeth. This is your pivot point. Again, when you actuate, this actuator allows you to get the 90 degrees of rotation on this probe to turn rolls 90 degrees. Again, a similar system, but this has for a 6-inch core. You can see that's a bigger probe designed for bigger cores on for 6-inch cores. So generally, these systems can be designed for cores up to about 18 or 20 inches in diameter, and all the way down cores down to 1-inch diameter. So there's quite a bit to choose from there, depending on most people run 3- and 6-inch cores, but if you have odd-sized cores, probes can be designed for that. This system I thought was pretty neat because it has a push plate built into it, which again, it has the controls mounted out here for the operator, and when you go to load a cantilevered shaft, you can see how these actuators actually push the plate, this plate right here, and will push the roll of material off onto a cantilever shaft or off onto a table or even the floor. But also the thing to notice about this, one of the things to notice in this photo, it kind of shows you how you never get that truly parallel positioning to the floor or to a cantilever shaft, because this pivot, this load point where the hook is, never gets to the center line of the roll. So you always have a little bit of tilt to these systems. Even these systems, if you think about when you hook up to this with a single overhead hoist, this position, this load position, never gets to the halfway point of the roll out here. So you'll always have a little bit of tilt with these systems, like it shows in this photo, and that could cause you some damage to the corner of your roll when you go to lay it onto the floor, or if you go to load a cantilever shaft, it may be difficult to do it because the roll isn't truly parallel to the to the shaft, or parallel to the floor. They're relatively simple. They're pretty easy to use. It only needs one hoist. The north to south rotation is real simple. It's just literally swiveling underneath a single hoist, and they can be more stable than a two-point system. And but the biggest disadvantage to these systems is that you can never get the true horizontal positioning to the floor with them. They can be powered with electric, pneumatic, or hydraulic actuators depending on what you have available and what's really best for the application. General advantages to overhead systems is they can all handle multiple rolls with one probe. You can have remote mounted controls, or you can have controls mounted right on the system itself. They can handle generally rolls up to about 2,000 pounds, and again, we're grabbing the roll by the core, so we're not going to damage the outside of the rolls. These units are designed to move, turn, and load and unload all with one piece of equipment, and they're very common. You'll see there's a lot of overhead systems out there to choose from, so you have a lot of manufacturers, a lot of designs, and a lot of different ideas, an idea pool to really pull from. Some disadvantages to overhead systems: they can't handle real heavy rolls of material. You could have trouble, as with any probe device, with grabbing plastic or metal cores, and core damage is always a concern if you're going to reuse cores. Telescoping is always a concern. You may need a vacuum plate to help you with that, and really, obviously, with overhead system, roll positioning is limited to wherever you have overhead in your plant. So if you don't have an overhead I-beam system out in, let's say, your loading dock area or over by your machine, you can't use overhead systems in those areas. Now, I just wanted to show some overhead systems that are used just for moving rolls around your facility. These are just probe devices alone. They don't do any roll turning. So if you have rolls that are already perpendicular to the floor, this type of device has a probe that will drop inside the core, has the teeth, and the teeth will come out and grab your core and allow you to pick up rolls and move them around your facility. But they're specifically not made for any kind of roll turning. This is a device that allows you to move rolls around your place, rolls that are already parallel to the floor. So if you haven't already, if you don't need to turn rolls again, and you don't need to worry about getting them perpendicular or handling them in the perpendicular plane, this particular device will allow you to move horizontal rolls or parallel rolls, move them around your facility. Next we have walk-behind devices, and really they're common for light applications. You'll see them mostly for roll weights up to 1,000 pounds, but they can be designed to handle roll weights up to 2,000 pounds. And walk-behind devices have both roll clamps that grab the roll from the outside and probes. We're going to show you photos of both. And they're self-contained. You don't need any overhead, and you just walk behind them. This is a clamp device. As you can see, it's manually operated. You just have some hand wheels that you turn, and these clamps will move in and grab the roll from the outside. This one's powered, but you can see how you're grabbing the roll. Here's your clamps. You're grabbing the roll from the outside, and you can see how unit has a drive that allows this plate to turn the roll 90 degrees from horizontal to perpendicular positioning. This is another example of a clamp device. This one has flanges that helps to stop if you have real soft rolls, and telescoping is a big concern. These flanges help to stop telescoping problem. This is another example of a manual device. You know, it's not powered, but you have hand wheels that move the clamps in, grab the roll from the outside, and also allow you to turn the roll 90 degrees, so you can see how it goes from perpendicular to horizontal. You can handle multiple rolls with one piece of equipment, but the rolls all have to be the same diameter on the outside. There are manual or powered units available, and generally designed for roll weights up to about 1,000 pounds. Core material is not an issue because you're grabbing the roll from the outside, and these units are designed to move, turn, load, and unload all with one piece of equipment. Some disadvantages: you're grabbing the roll from the outside, so some rolls of material may not like that. You may damage the outside layers of some materials, and they're really not designed for real heavy rolls. If you're going to have a powered unit, you got to have a battery or something that travels with the system that's going to be required to be recharged from time to time. This is a walk-behind device that uses a probe. As you can see, here's your probe out on the end. You would walk this device up to a core. This roll is perpendicular to the floor. You can see how you drop the probe inside of the core, and then you get the roll up in the air and turn it 90 degrees. This is an example of the same type of system. Here's the pivots. The probe is inside the core right now, but this probe pivots 90 degrees to give you the perpendicular positioning and parallel positioning. You can see how this is loading the unwind shaft of a slitter. This is a walk-behind device that has a flexible probe, and you have this can be powered or manual. This one has manual hoists, but when you turn these cranks, this hoist will pivot the roll 90 degrees to go from perpendicular to horizontal. You can handle multiple rolls with this type of equipment. They can be manual or powered. It can handle roll weights generally up to 1,000 pounds, and we're grabbing the roll by the core, so there's no outside roll diameter damage. You can move, turn, load, and unload all with one piece of equipment. Some disadvantages: they're really made for light to medium duty applications, and again, with any probe device, you could damage, or you have to be concerned about metal or plastic cores. Sometimes the teeth won't dig into those cores and grab them. Core damage is always a concern. Telescoping rolls is always a concern. And again, if you're going to have powered units, you're going to have a battery that travels with the unit and will require recharge from time to time. These are some walk-behind devices that don't do any roll turning. They just move rolls around the facility. This one I thought was pretty neat. In the boom that holds the roll, there's ball bearings mounted all the way across this unit so that the rolls slide on and off very easily. This is another example of just, again, it doesn't do any turning of rolls, just for picking up rolls and then aligning them with an unwind shaft on a slitter. This is a walk-behind device that cradles the roll on the outside, so you can see how a roll would sit in this cradle, allowing you to move them around your facility. This one has a push plate built into it, so again, it doesn't turn rolls, but it does allow you to pick up parallel rolls, heavy rolls of material, get them up in the air, and then this powered push plate pushes the roll off onto a table. This one's a table, but it could also push it off onto a cantilever shaft. Next, we have tilt table devices, and they're designed for very, very heavy rolls of material, up to 10,000 pounds, and they can be loaded with whole pallets of materials, so they can handle very heavy loads and very large amount of rolls as well. And they turn rolls very gently, and there's no concern with damaging rolls or telescoping. This is a good example of a tilt table device. Basically, this whole table pivots 90 degrees to turn very large loads or even full pallets of material 90 degrees. And this is the unit halfway through its rotation. So you can see how you're going to be able to load this up with rolls of material and pivot rolls 90 degrees. And then this is a smaller unit, but it gives you the same idea. Again, this tilt table device pivots rolls 90 degrees. Some advantages, you can turn a lot of rolls all at the same time, 90 degrees. You completely avoid telescoping, and they can handle very heavy loads. Disadvantages, the tables are stationary, so you have to get the rolls of material to the table, then turn the rolls of material, then get the rolls away. So turning rolls and moving rolls and loading and unloading are done with different pieces of equipment. Lastly, we have robotic systems, and basically they're available in automatic and also semi-automatic models, and really they greatly limit or completely eliminate people from having to handle rolls of material. So they really are the ultimate in safety and efficiency. This is a good example of a semi-automatic robotic system. This is the rewind side of a slitter. These rolls are slid off the rewind shaft, and then there's what's called an articulating arm that the operator operates, and there's a probe at the end of the arm that grabs the roll, and when you slide this roll onto these shafts here, these shafts pivot to this position and allow the operator to basically stack rolls of material onto this pallet, and then the pallet go to your shipping department or wherever, or your storage. Another semi-automatic robotic system, rolls of material are slid off onto these cantilever shafts, and these cantilever shafts pivot and then drop the roll onto this conveyor belt, and then that goes off into a packaging department. This is a completely automatic robotic system. The articulating arm is all robotic in nature, and you're grabbing the rolls from the outside with clamps, and the arm literally slides the rolls off the rewind side of a slitter, and then we'll place them onto a skid or wherever you want to put them into a packaging, however your shipping department accepts them, or your storage department. Some advantages to robotic systems is you're basically taking people out of the mix, so you're eliminating people from having to handle rolls at all, and so they are by far the most efficient systems available. Disadvantages, they're very complex. You have a lot of mechanical and electronic systems all working together, and if you're going to change your machine setups, you got to reprogram your roll handling device, and obviously by far the most expensive type of roll handling equipment. Now, there's a lot of things to consider when thinking about roll handling equipment for your facility. We've covered a lot of different types of roll handling, and you have to keep in mind that each is really well suited for specific applications, and each type of roll handling equipment is somewhat customized or custom manufactured for each application it's applied for. So when you're thinking about roll handling equipment, there's some information that you're going to want to have readily available for potential suppliers. You're going to obviously need to know how heavy your rolls are. Do you want to move rolls? Do you want to turn rolls, or do you want to do both? And what's the width range of your rolls, minimum to maximum? We also want to know the roll diameters you want to handle, again, minimum to maximum. What core sizes? What's your core range that you use in your facility? What are your cores made out of? And if we're going to be dealing with probes in that, will core damage affect other operations in your facility? If you're thinking about roll handling devices that grab the roll from the outside, you have to think about, are the outside layers of your material delicate? And one of the important things to always consider when you're thinking about roll handling equipment is, how efficient do you need the system to be? Do you need to be able to load and unload rolls of material off a machine once every 10 minutes, once every 15 minutes, once an hour, once a day? And that really comes quite a bit into play when you're thinking about roll handling equipment, because each type operates within an efficiency range. If you're thinking about overhead systems, do you have the overhead I-beams and trolley system existing that you can tap into that system, or do you need to add that as well? Now, one of the most important things when thinking about roll handling equipment is get everyone involved in the decision-making process, especially the people that are going to be using the equipment. Oftentimes when I'm in the field and I see roll handling equipment, it's kind of tucked off in the corner and people just don't use it. It's because the machine operators feel that they can do their job better or faster or more efficiently just by manhandling rolls, and that may not be the best way to do it. So really should get everyone involved in the process, especially the people using it, because you want to make sure the equipment is designed so that people will use it. And again, if people think they can do their job faster and better by not using the equipment, they just won't use it. So that consideration is very important when thinking about roll handling equipment. And bottom line, if you buy roll handling equipment and it's properly applied for your application, it will greatly improve your bottom line, because you'll have less injuries in your facility, and also you'll be able to properly handle rolls so you have the least amount of roll damage to your rolls. So profits will increase. That's the end of the webinar. If there's any questions, you can feel free to type them into the chat box, and I'll try to answer any questions. And you can always email me at any time. My email address is there. It's demore@epix.net, and you can email me any questions. There is a free white paper that goes with this webinar, and I'll be happy to email that to you. Or you can call us and request the white paper, and we'll either email it or even send you a hard copy if you require it. But if you send me an email and ask me for the white paper, I'll be happy to send that to you. Again, my email address is demore@epix.net. And I'd like to thank you for attending this webinar on roll handling, and also make you aware of a webinar that's coming up on web spreading. So if you'd like to know more about how to remove wrinkles from your process, we will discuss that. And it's the web spreading webinar. You can register now, and you can register at our website, www.converteraccessory.com. And it's a very well received webinar, and there's a lot of information in that webinar on anti-wrinkle devices. And actually, it looks like we don't really have any questions. So again, I appreciate your time, and thank you very much for attending CAC's roll handling webinar.